In this video, we're going to look at how to find the lowest common multiple, not only of numbers, but also of monomials, of polynomials. We're really going to get in depth so that when we're working on solving rational equations, we are able to figure out the LCM for anything we need. All right, well, let's start off very simple. We're going to start off with two really easy numbers. So I'm going to say find the LCM of 6 and 9. Really easy. Just so you can understand what LCM means. So of 6 and 9. Sorry about the really horrible handwriting here. All right, so what is lowest common multiple? Well, if we list the multiples of a number, so the numbers, like for example, for 6, we have 6, 12, 18, 24, on and on and on. Those are multiples because you're multiplying. And for 9, multiples are 9, 18, 27, so on and so forth. The lowest common multiple is exactly what it sounds like. It's the lowest number that both those lists have in common. So if we look at that list and that list, then the lowest number that they have in common is 18. So in this case, our LCM is equal to 18. But that's just the very beginning level. Let's look at one that is harder with harder numbers. Okay, so this one is significantly harder because we have bigger numbers, we have more numbers. There are 3 numbers in this case. And yes, we could patiently start writing out the multiples of each of these numbers and see where you get the lowest common one, but it's going to take a while and it's going to be really annoying. So here is how we do this question. In order to figure out the LCM here, you want to find the prime factors first. So let's just put that bullet point here. We want to find the prime factors, and I'll go over how to do that in a second. And then we want to take the prime factors and we want to multiply them by each other, but not all of them. You want to multiply the prime factors the greatest number of times they occur. And I'll make that clear. When you see it happen, you'll understand what I mean. So you're going to multiply them the greatest number of times that they occur. So let's just put that here for now so we can refer back to it. All right, how to find the prime factors. All right, so let's start off with 20. In order to find the prime factors of a number, we can use something called a factor tree. So we think about what's the lowest factor of 20 other than 1, and the lowest factor of 20 other than 1 is 2. What multiplies by 2 to get 20? That would be 10. All right, and then so we take that and we make another set of branches. So 10 also has another factor other than 1. And the factor other than 1 that multiplies to get 10, the lowest one is 2. And you multiply that by 5. And now 5 right here is a prime number, so it's 2 and 2. So these are actually all the prime factors. So I'll circle them here because 2 times 2 times 5 gives you 20. So those are the prime factors of 20. Let's do the same thing for 44 and 88. So 44, all right, so 44, the lowest factor other than 1 is 2, and that matches up with 22 to give you 44. The lowest factor of 22 other than 1 is still 2, which matches up with 11. And then the 11 is prime, so we've actually made it all the way to the end. 2 times 2 times 11 gives us 44. All right, time to do 88. So 88, the smallest number other than 1 is 2, which matches up with 44. We already actually did the 44 over here, so now we're just going to repeat those. We have 2 and 22, and we have 2 and 11. So the prime factors of 88 is 2 times 2 times 2 times 11. All right, so we're going to multiply the greatest number of occurrence for each of these prime factors. So here we have 2 that shows up twice here. It shows up twice here, but it shows up 3 times here. And we're paying attention to where it shows up the most. So we're going to take those 3 2's, and we're going to have 2 times 2 times 2. All right, so the greatest number of times that the 11 shows up is once. It only shows up once here, it shows up once here, it only shows up once for the most part. So once, and 5 shows up once here. So the most that 5 shows up is once as well. So when we multiply all those numbers, we should get the lowest common multiple, which is 440, and it's correct. So if you ever have a problem where it's hard to see all the multiples and see which one is the lowest, you're going to have to go through this prime factorization process and complete the question this way. But now moving on to the good stuff where we start introducing some variables. Okay, so now here we have a monomial, 2 monomials, and we're asked to figure out what the LCM, the lowest common multiple, is. So if you have to find the lowest common multiple and variables are involved, numbers are involved, just make sure you find the lowest common multiple of each part, the numbers and each of the variables. So here we know that the LCM of 3 and 9, that we know because we just practiced that. So the LCM of 3 and 9 is going to be equal to 9 because that's the lowest common multiple of both of them. Now the lowest common multiple, now I'm going to look at the x's. I'll call it x's like that. So the lowest common multiple of the x's, you're going to look at how many x's occur the most. Just like we did before when we were looking at the prime factors. So what is the x's that occur the most? Well, we have here x squared, and we have here x to the third. So the x's that appear the most is the x to the third. So x to the third is the lowest common multiple of the x's. And then we have to look at the LCM of the y's. And again, we're going to look at the y's that occur the most. So we have y to the fourth here and y to the third here. So the y's that occur the most is the y to the fourth. All right, so here we have y to the fourth. So in this case, our LCM is equal to 9x to the third, y to the fourth. All right, so one more example of how to figure out LCM, and we're done. Okay, so I left the best one for last. So if you have a polynomial or a couple polynomials and you want to figure out, or a few polynomials, and you want to figure out the LCM, you have to make sure that everything is in factored form. So here we are all set with this one because this is already just p minus 1. There is no square, there is nothing happening, there is nothing to factor out in this case. But this one needs to be factored. So you have to always check that it's in the most factored form. All right, so let's factor the second one here. So when we factor that, we get p minus 2, p minus 1. So really, we are trying to figure out the lowest common multiple of p minus 1 and p minus 2, p minus 1. So once it's in factored form, what you want to make sure is that you include each factor that occurs. So p minus 1 occurs, it occurs here and here, but the maximum it occurs in each one is just once, so we only need it once. So p minus 1 and p minus 2 also occurs, so we need that, so p minus 2. And we don't have to FOIL it. All we have to do is just make sure that each factor occurs and we're good. So this is our LCM. And that's it.